So example 2, consider these functions. The function f, animals to counting numbers, assigns to each animal the number of legs it has. Function g, people to animals, assigns to each person his favorite animals. Describe which composite functions are defined. If defined, describe the action of each composite function. So letter A, f of g. Now, the first thing we have to remember about composition is we do it from the inside out. So I'm actually going to focus on composition of g. What's going on with function g? So my input is people. So in function g, I would put in a person, and that person would give me an animal. So the output of g is an animal. I take that output and I put it into function f. The input of f is also an animal. And the output is the number of legs for the animal. So this is a function which is defined. So I can say that this function is defined because I can complete the process of starting with function g and using my output from function g as my input from function f. Now here I've got f of f. So my input to f is an animal, and my output is a number. But every function f requires the input to be a number. So my output of a number does not provide the input required. So when I get a number out of this function f, I don't have an animal to put in this function f. So that's why this one is not defined. So I can't do a composition of f of f. Now, when I come over here of g of f, remember, we do the f first. So if I do f first, what it says is I start with an animal and I get out a number. So my output is a number. But my input to G requires people. Since my number can't be replaced by people, this is not defined. And finally, f of g of g. We start at the right, deepest inside, with that g. So my input is a person, my output is an animal. So I have an output of an animal. My next input has to be a person. So does not satisfy the input of a person. So again, this composition function is not defined. So when we look at our composition functions, the only one that worked was the one that had a shared output-input relationship. When you look, notice that the output of G, being an animal, has the input of F, being an animal. And so we can make the transition from this output to this input to bring those two functions together. So if the range of one function does not match the domain of the other function, then you will never get that composition relationship. And that's example 2.